Last week I was still working on the testology-based thresher test and made some progress. We had the first recovery backfill bug. I'm pasting the URL to the tracker ticket in the chat window. I will try to look at it. And apart from it, I also ported some basic test, namely the test exercising the OSD operations to Crimson, and all of them passed after cutting off the unsupported features. And I'm also pasting the URL to the test window. Also, along the way, I fixed and added some issue and missing operations for supporting the test. That's it. Shimei.
I updated the extend map tree according to your comments, and please review. And still working on the OMAP tree node implementation. So that's all.
Too bad I cannot hear him.
Can you hear me, Kefu?
I'm hearing you. Julia.
Hello? Ringing, can you hear me?
Yeah.
Okay.
Yeah.
So that's me, maybe Kefu's side had some problem.
Okay, now.
Oh, okay. Oh, Kefu.
That's on my side.
The same work as last week, just updated the extend map tree PR according to your comments, and still working on the OMAP tree node implementation. So that's the two tasks. So that's all. Thank you.
Brendan.
Hi, everybody. Same as last week. Finishing touches for PR for scrubbing. That's who I am. And reading the PRs. Just to let you know, I'm not adding comments to the PR on the new, because I'm not sure I understand enough, but I'm reading. So
Which PR you are referencing, Brendan?
Today I read I read most all of them, but today I went over over. I think it was yours or Radek. You and Radek commented on. Where is it? 1 second, it's still open. Never mind.
I think most of my PRs are very straightforward. Numerical thing.
Yeah, they added the functionality to edit ops.
Yes.
So,
yeah.
No.
Okay, thank you. Stem?
Yep, I sent out a PR for the dirty extent whiteout. So I'm moving on to general garbage collection. It will use the same extent rewrite machinery. The new code will be scanning segments is the main part. But the code for changing mappings already exists as part of the PR I submitted. Can you hear me?
Yeah,
in other words, the code for rewriting a dirty extent is the same as the code for rewriting an extent that is not dirty, but is in some other segment. The new code will be in scanning segments. Does that make sense? In other words, when we rewrite a dirty segment, we have to write it out, or I'm sorry, not a dirty segment, a dirty extent. We have to write it out to a new location on disk in the new segment, which means we need to atomically update the LBA mapping to point to the new location and generally make sure we didn't break the cache. So that's what that PR is. The next step is space accounting, so we know which segment is the right one to garbage collect. And the code from walk. I'm sorry?
So what
space.
Space accounting. Okay.
Space accounting. Just a quick summary. My strategy here is not to do something smart. I'm going to do something very stupid. I'm going to maintain an in-memory counter for how many live bytes there are in every segment. I assume that the overall number of segments will be relatively small as we control the size, so we can make that be true. On OSD startup, it will simply do a complete scan of the LBA map and rebuild that ephemeral mapping. And it will just maintain that mapping inline during execution. In the future, we may want to make this smarter so as to make OSD startup faster, but this should give us more than enough to do some basic performance testing. In that we won't run out of space. It'll work correctly. It'll just be slow.
I'm curious, when do you plan to do the garbage collection?
Now. That's what I'm doing now.
No, I mean when, like when we do some write operations or the free space on the threshold.
Right. So my strategy in somewhat more detail is I want to specifically avoid. So BlueStor has this property where you can build up kind of an unbounded amount of asynchronous work that it then just does eventually. In the form of that big RocksDB garbage collection phase where it has to go through the entire level and whatever, and the level below it. It has to read and write all of those LSM blocks, and a lot of that tends to interrupt I/O. So I'm not going to do that. What it's going to do instead is it's going to maintain an estimate of, well, it's going to maintain a number that represents the amount of space that is available to be written right now, an amount of space that is currently free, an amount of space that is not available to be written but is free. That is, if we garbage collect it, we'll reclaim it. An amount of space that is currently in use. And the thing I just outlined does give us that ability. We'll know for each segment down to the byte how many bytes we have to relocate if we garbage collect it. We just don't know where they are.
Yeah.
So that should give us a really granular notion of how much work we have to do for each and every transaction to make sure that we tread water. So I'm going to maintain sort of a soft and hard limit. If you're below the soft limit, we don't do any background work. We just do foreground work. And anytime we have slack time, we'll do background work to get us down to an even lower threshold. Between the soft and the hard limit, it'll exponentially scale up to doing as much work as the I/O is generating until you hit the hard limit, at which point you have to pay as much background work as you do on every transaction. If you're going to consume X bytes of space, you also have to free up X bytes of space.
So if we hit the hard limit, all the from load will be stored, right? And
it won't be stalled. It's that every transaction will have to also do a certain amount of background work. If you need to write 1 megabyte, you also need to scan a megabyte of segment. So it'll just inline. Okay. It'll mix them in line so that we never get that. Well, hopefully we never get that gigantic spike that costs many seconds. But we also don't get those bursts of crazy speed where we didn't do any background work. I mean, unless we. So with luck, it will be the same average pace, but without the big outliers. So it'll be easier to predict and easier to schedule. But this is like the first implementation, so I'd be shocked if it works well. We'll have to do several. Yeah, this will be an area where we have to improve a lot. But at least for the first version, it should be predictable.
Yes, that makes sense. Thank you.
You notice the current PR has the first step of that. It's got that do immediate work. That's the entry point where the segment cleaner will do what it feels like it has to do on each transaction. And then there will be another call that will be cycled in at a different point in the transaction when we're not actively processing I/O for catching up in the background. So those will be the two entry points. Never mind though, sorry.
Okay, so you already have a minimal implementation of a GC in your PR, right?
No, the current implementation, what the current implementation does is it bounds how many journal replays. Without my current PR, your memory use will increase proportional to the number of extents you have ever written to a second time, because there's no way to flush dirty extents.
Okay.
What the new code does is the other thing we have to maintain is we have to make sure we don't have an unbounded amount of journal to replay. So the first thing I did was I implemented it. You can give it a soft and a hard limit for, it will make sure you never have to replay more than 2 segments, let's say, worth of journal entries. So with every IO, it will write out any dirty extents that are that old, thus ensuring that we can actually write out and release things from the cache. And also, it has I believe all of the logic that will be required for relocating an extent. So I will reuse that exact pathway when doing GC. That is all of the LBA modifications and cache modifications that were required to rewrite an extent. That is to take a logical extent, copy it to a new physical extent with the same logical address, and then update the transaction so that it updates the LBA pointers from one to the other, thus effectively relocating the logical extent.
So when doing one more thing, so when doing garbage collection, we're likely to relocate a logical extent without changing its logical address, but we change its physical address because
precisely.
Okay.
That's the reason for the logical address. Otherwise, when we moved it, or every time we moved something, we'd have to reach into a whole bunch of extra structures that are hard to predict. This way, we only have to update the LBA table.
Sure. Yes, that makes sense. Thank you. I'll take a look at it ASAP.
It's actually not a huge hurry. I'm just going to move on to the next bit. But if you want to, by all means.
Oh, I don't have it.
As in, I'm not blocked. I'm not blocked, in other words.
Okay. Johan.
Future.
You're muted. Okay.
Okay, can you hear me?
I can now.
Okay. I'm still debugging the interruptible iterator future, and it turns out that the interruption machinery is a little bit more complicated than I thought. Actually, the interruption-related error need to be dealt with differently from a common iterator error. So I have to add a little more code for that part. And this is the branch I'm working on now. And during the debugging, I also met this issue, and it turns out a lot of problem I met during my debugging is due to this issue, and I have to fix it first before I can fully test the interruption code. And if anyone else wants to take a look at it, that'll be appreciated. And that's all for me.
Thanks, Johan. Yinxin, did you get a chance to check out this issue? It seems like you've already fixed it.
Yeah, I have looked at it today, and seems to me it is not a fatal issue, because after like 5 seconds, the heartbeat connection will reveal itself correctly in the log. So there's actually there is an issue in the current code, because a reset event is not correctly generated to the heartbeat. So I think that's a root cause of it.
You mean the issue is underneath of the heartbeat machinery? It's in the messenger. Is that what I mean?
Yeah, messenger. Yeah, the messenger doesn't report the reset event to the newly replaced connection. So the heartbeat holds that closed connection and reject to accept the new connection later. So during that period, the OSD, the peer OSD will send heartbeat to this OSD, but this OSD will not send to the other side. And after, like, for a while, after this peer is removed and after it is added again, that peer is connected. So that's why I think it's not a fatal issue. It can kill, but there's a sad event in it.
Per explanation, it sounds it's expected behavior because we need a grace period so they can drop the connection, right? So they don't race with each other.
No, no. There is actually an issue that there's a missing reset event causing that connection break, and but it will heal itself after like 5 seconds in the log. So that means it's not a fatal, but it should be fixed.
Okay, thank you. I will send this issue to you if you're fine with that.
I will reply in that issue.
Thank you. Yixing?
Okay, so this week I have integrated aerated feature and with transaction manager interface, and the unit test is migrated to the SeaStor Google test framework. And currently I'm integrating the logical cached extent, and I have looked at the LBA map and the LBA tree and the OMAP implementations. I think the solution will be differently because the node layout and the in-memory node structure and extent are decoupled in the ONode tree implementation. So there must be some different implementation to integrate the logical cached extent to implement Delta facilities.
So you mean the Delta block used by extend, for example, the extend block should be different from that used in your ONode tree.
Design is,
yes, I think so.
It's different.
Okay. Anything else?
No.
About the issue that I submitted, just one thing I want to note is that there are chances that the OSD key pop-up the error don't reply from the other OSD due to that issue, and I think because to fully test the interruption machinery, I have to shut the OSD down and start it again, and this issue is actually severely impacting that process. Okay. And okay, so I just want to know this. And
do you mean after the issue happened, if you don't shut down the OSD, does that issue continue happen or not?
Yeah, it continues.
I will take a look.
Is there anything else?
Yeah, I wanted to ask about one thing. This is just about sort of I think a while back someone mentioned Micron's, I want to say, heterogeneous storage engine, maybe? I think it got open source sometime in May. I talked to them sometime last year. But they're getting the kernel components upstream somewhat soon. That is, the Red Hat kernel team is helping them get their patches in shape to actually merge. So I met with them a bit and looked at it, and it has a few interesting properties. So they seem to have actually designed it to operate as a backend for a Ceph OSD. Its real target, honestly, is to replace Wired Tiger or RocksDB as a key value store, but there are features in it that they say were designed to address use as an object store implementation for a Ceph OSD. To wit, its transaction implementation is powerful enough to be used unmodified, as far as I can tell, which means that implementing an object store layer on top of it would be quite trivial. You wouldn't actually implement transactions, you'd simply use theirs and just do a very simple mapping from the OSD's sort of object abstraction to a collection of keys. And their keys support mutable.
Do you have keywords?
Micron heterogeneous storage engine. This isn't something I plan on devoting much time to, but I do plan on slapping together an object store implementation for classic OSD. It's not possible to do one for Crimson yet because they don't support asynchronous I/O, but they are working on it. They're going to use libiouring, or they're going to use IOUring rather to support asynchronous I/O. It just isn't done yet. Anyway, so I think that might be an interesting thing. We will see what comes of it.
So there will be upstream to the Linux kernel very soon, right, with help from Red Hat.
Very soon is one of those optimistic terms. I'm going to go with the more we want it, the faster it'll happen, if you know what I mean. So that's the thing. It doesn't have any big users. So hypothetically, for us to use it would probably mean we would be the only major user, which is a significant mark against it. However, so that at that scale, it would basically have to replace something like SeaStor to be worth the engineering cost. But I'm all in favor of not writing an object store. That sounds great. So if I have time to, I'm going to try to find some time in the coming month or two to either wire it into classic OSD or conclude that it's stupid, one or the other, or conclude that it's not worth working on.
Yes, the sooner we make the decision, the better.
It's not going to be like that. I don't think there's any way it's going to be a direct trade-off, and I don't think we're just going to I don't think we're going to do a prototype for this and go, oh, I guess we're not doing SeaStor. I think that it's going to take them several more months to get it in kernel in the first place, and it will take quite a bit longer before we find out whether it's performant and stable. So I don't think it's that kind of hurry, particularly since we literally can't use it for Crimson yet, because they haven't written the asynchronous code paths. And it may be difficult for them to adapt them. We will see. But I do think it's an interesting thing to keep on the horizon.
No, they do have a asynchronized code path interface or not?
They do not.
Okay.
They will. They are working on one, but not as urgently as they're working on getting the patches upstreamed. So in other words, they have a fair amount of technical work to do before they're going to really work on that. And I don't know how much they have to do at the user space level, because the vast majority of it is user space code in library form, not the kernel component. There's a fairly thin kernel component. That's what they're getting upstreamed. But in order to offer us an asynchronous interface we can use, not only would the kernel have to support IOUring, the intermediate code paths would all have to be asynchronous as well. So I haven't evaluated it far enough to know about that. Anyway, I just think it's interesting.
Yes.
At least when I first looked at it, I just assumed the transactions weren't powerful enough, but it looks like they might actually be, or at least they claim that they are. So.
Thank you. We post the.
That's the thing. Yeah. Well, I mean, hang on. Let me just give you the GitHub link. Their documentation isn't the best, but honestly, for a fairly early stage project, not the worst. Let's see here. It's this one. There you go. At the moment, in order to even test this, you need to get like a RHEL 8, CentOS 8 kind of thing, and then build their kernel module, install it, build the library for it, and then build the actual project. It's a little rough. It will be some time before it's packaged in a way that people can use it. If nothing else, we should be able to steal ideas from it, right? However, the upshot of all of this, and the reason why it's worth entertaining this at all, is that it should, in theory, on spec, already support persistent memory and zone namespace devices in a heterogeneous configuration where it uses, the faster storage for caching, all of which is like a lot of work. So,
you happen to know what the key data structure they are using, like RSM or something?
They're not using an LSM. Or at least I don't think they are. I'll have to check. I suspect that they're doing several
too.
different things depending on how you have it configured. It's pretty configurable.
Because it sounds like they are include results from RocksDB, so they should be using RSM.
No, that's not true. No, that's not true. You compare against RocksDB because RocksDB is popular, not because your implementation is similar. In fact, you typically compare against RocksDB because RocksDB is quite slow, and every key value store looks good when compared against RocksDB.
Okay. So could it be some
like Wired Tiger is some kind of memory-only, like direct table thing. That's not NullSM.
Okay. Anyway,
I think it's interesting. I'll try to find some time to look at it the next month or two.
Me too. Anything else?
Nope, not for me.
Okay, talk later. Thank you guys, and have a good one.
See you.
See you.
Yeah.
Bye.
Bye.